Hi everyone! So for those of you who don't know me, my name is Ms. Hu, or you can call me Teacher Zien. I am a high school teacher specializing in physics. For this video, I will be focusing on how to answer the SPM Physics Paper 3, targeted at candidates who are supposed to sit for the SPM 2020 paper. But as we all know, SPM has been postponed to February 2021 because of the unfortunate pandemic. So for those of you who are taking SPM 2021 at the end of the year, it is a different format, so I'll cover that in a completely different video. So I'm targeting your seniors first to help them get through the upcoming SPM, which is really soon. Now, this is kind of like my first video, which I am doing to explain how to answer these questions. So the video may be a little bit rough around the edges. So please bear with me and forgive me for any mistakes. If you do find any corrections that need to be made, please drop them in the comments below and I'll be happy to address them as soon as possible. For the purposes of this video, I will be focusing only on paper 3 section A and I will cover section B in a separate video. To make it easier for you to follow my video, please get hold of the SPM 2019 paper 3, which I'll be using in this video. But please bear in mind also that the methods that I will be explaining on how to answer this paper can be used for any paper 3, any of the past year SPM papers or trial papers or model papers. So please bear with me because I don't actually have a script. I'm just speaking as I go along, but I'm going to be sharing my knowledge with you in terms of how to answer the paper 3 as best as you can. The reason I'm focusing on paper 3 for the first video is because for a lot of students, they find paper 3 scary and they think that it's difficult. But to be very honest with you, among the 3 papers for physics SPM, your paper 1, paper 2, paper 3 is actually the easiest to score. So no matter what your level is, whether you're already an A plus student, or if you're a student who's just struggling to at least pass, you should focus on paper 3 in order to maximize the marks that you can get. Because to be very honest, again, paper 3 is the easiest paper to score. All you need to do is you need to make sure that you answer based on the format that is required of you. So without further ado, let's get started. So I'm going to be using the SPM 2019 actual past year paper for this example. But like I said, the methods that I will be discussing in this paper can be used for any SPM paper 3 samples, right? Okay, so here we go. So let's start. So this is the actual SPM paper 3. We're going to do section A only for this video. Let's get started with question 1. Now, as you may or may not have noticed, paper 3 only has 2 sections. You got section A and section B, and section A is made up of 2 questions. Section B is made up of 2 questions, but for physics SPM, you just need to answer only 1 question in section B. For section A, you need to answer both. And the format is kind of fixed. You'll see that question 1 always requires you to draw a table and draw a graph, and question 2 will give you a graph. Let's take a look. So let's start with question 1. Now, in question 1, do make sure that you read the entire question carefully. Okay, and you get like a whole bunch of pictures here with pictures of measuring instruments. You do need to take readings of these measuring instruments, right? And of course, you need to get the values. So what I'm going to be focusing on right now is not so much the answer that you need to write. I'm very sure that all of you know how to read the measuring instruments, like in this case, the milliammeter, right? Some past years you might see you get a ruler, some you might get stopwatches, some you might get voltmeters, okay? I'm sure all of you know how to take a reading from here accurately. I'm going to be focusing on what you need to do in order to get the marks that you need. So the very first question, A, always asks you for the variables, which are the manipulated, responding, and constant variable. Now, don't crack your head so much in order to get the answers for the first 2. Always go back to the very first line of the question. I'm scrolling back to show you. It's over here in the very first sentence. Right, so you'll find that it's always a student is carrying out an experiment to investigate the relationship between something and something. So in this case, you've got base current and collector current. Don't crack your head so much. One of this is your manipulated and the other is your responding variable. Now, which is which? Of course, take some time to read the question. Don't expect the answer to be handed to you on a silver plate, right? You'll find that, okay, you've got this milliammeter here. This is for zero error. Let's look at another one. You got a milliammeter here, and look, they've given you here IB equals to 10 microampere, and you've got to fill in this value. Now, whatever they've given you here, this is obviously the manipulated variable because that's what's being controlled. The responding variable is the reading that you're supposed to take, which means that because you'll find that the experiment is done by adjusting the rheostat to set the value of the base current to obtain the corresponding value of the collector current. This obviously means that the base current is your manipulated variable and the collector current is your responding variable. So don't think about, reading of the milliammeter is our responding variable and all that. Don't make it so complicated for yourself, right? Make it as easy as possible for you to get the answer, which means that based on the very first sentence that we saw in the question, this means that, hold on, let me get this. Let's put this away. Apologies. This app is actually quite difficult to use. I don't like this app very much. I've been trying to get a different app for the video, but it wouldn't work. That's why I'm forced to use this for the time being. Okay, so which means that the base current is our manipulated variable and the collector current is our responding variable. Then there you go. You've got 2 marks, just like that. So you'll find that most of the answers are in the question itself. Now, with regards to the constant variable, of course, sometimes you won't get the answer directly in the question, right? So how do you figure out the constant variable? Now, one thing that you must remember with regards to variables in physics, and we're talking only about physics here, not chemistry or biology. When it comes to variables, whether it's manipulated, responding, or the constant variable, all these variables in physics must be physical quantities. If you have forgotten what they are, please go back and refer to Form 4 Chapter 1 to refresh what physical quantities are. All right? So you must make sure that whatever variables you write here are physical quantities. There are a few exceptions to this rule, but usually very far and a few in between. So usually physical quantities you're expected to write have to be something that can be measured. That means you have a number, for example, base current, collector current. It could also be length, time, temperature, volume, area, depending, of course, on the experiment in question. The only time where a non-physical quantity could be accepted could be, for example, if you're talking about the material of the conductor, for example. But in most cases, there is physical quantities, so please look for a physical quantity to write in all 3 answers. So with regards to the constant variable, that doesn't mean that you can write any random physical quantity and that's accepted as a constant variable. That's not true. In the case of the experiment, you need to look for a variable which, if you do not keep constant, can change the value of the responding variable. Let me say that again. When you're looking for a constant variable, always look for something which can potentially modify the responding variable. So this is normally a factor besides a manipulated variable. That means you got to have a little bit of physics knowledge, of course. So if you find that in this particular experiment, the manipulated variable is one factor which can affect the responding variable, and you know of other factors, those other factors, that's the constant variable. Now, what if you're like, okay, but in this particular experiment, we're not looking for a factor that's affecting this in this case. I have no idea what the constant variable could be. So you gotta use your logic a little bit and look at the question, or rather look at the experiment and think, okay, If I modify something here, what could make the collector current change? Let's say something else besides the base current. If I change the material of the wire, or if I change the transistor, or if I change the number of dry cells or the voltage of the dry cells, will the collector current change? If your answer is yes, then potentially one of those is the constant variable. So in this case, for example, we could go with, let's say, the voltage of the batteries. Yeah, think about it. If we put in, let's say, for example, we in one experiment we put, let's say, 6 volts, and in another experiment we put 10 volts. Wouldn't the collector current change? That's possible, right? Which means that needs to remain constant, because the only factor that we are investigating is a base current. We don't want another different factor to affect our results. Which means that in this particular experiment, there is a number of different variables. But the important thing is you got to remember that the constant variable has to be something which can potentially change the responding variable. If you find that changing this particular variable has no effect on the responding variable, that's not a constant variable. Okay, I hope that makes sense. Okay, so in this case, there's a whole bunch of different answers. I'm just going to write one just for a reference here. For example, we could go voltage of batteries. Now, so with regards to the recording, the reading, and all that, so I'm not going to focus on the numbers here, but I will focus on how to present the numbers. Let's go back to the zero error here on this page. All right. Now, let's take a look at this milliammeter and take a look at what the value could be. Now, I know all of you know how to read the milliammeter, so let's take a look and see what the value is and how much is it. That's right, it's only 1, correct? Because you find that, okay, 10 up to here, and there are, this many number of divisions, which means this is obviously 1. So I'm going to use the freehand tool just to make it easier. Let me go faster. So it's 1 milliampere. Then you must remember that when you record this value, it has to follow the sensitivity of this measuring instrument. So take a close look and let's see how many decimal places does this milliammeter have. Does it have like 1 or 2? What do you think? Yeah, for some of you who said no, but there's no decimal place. Yeah, you got it right. There is no decimal place because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So keep this in mind, because there is no decimal place. That means that when you record the value, no decimal place. If you think like, wait a minute, that looks really funny, and you decide, okay, I want to be a little bit smart here, I'm going to put 1.0. Oh, maybe it's more accurate if I have an extra decimal place. Yeah, don't be too smart, all right? Because if you add decimal placing, wrong. It's not the value that we're looking for in this case. There are two things we're looking for. We're looking for the value as well as the sensitivity. So don't think, oh, as long as I got a value correct, it doesn't matter how many decimal places I have. It doesn't work that way. You've got to have both the value and the sensitivity. So if this measuring instrument has no decimal place, you must not write any decimal place. I'm going to throw this away. And remind you once again that when you write this, follow the decimal places. And this applies to all the values that you see in the diagram. So for example, in this case, if this is 9, don't write 9.0, it's just 9. Okay. And if you've got here, for example, 17, this is only 17, not 17.0. Okay. And so on and so forth. Okay, okay, so when you then prepare the table, tabulation, you've got IB, ICX, and IC in this case. So look at how many symbols that they have here. There are 3 symbols, and there are 3 columns that you need to write. Always remember that the columns must go downwards and not across. Okay. Yeah, because that format also counts. For SPM, it has to go downwards and not across. So when you do this, let's do the freehand. Let's hope this works out. So we've got IB, ICX, and IC. So some of the things that you must remember to have, besides what you call the symbols here, is you must have the units. So you've got microampere. Whoops. Yeah, this is why I don't like this app. Okay, milliampere and milliampere. So when you record these values, please remember to follow the sensitivity of the instrument as per the diagram. So like for IB, you don't have to measure. It's given to you here, right? So you just write down. You see, okay, what's given here? There's no decimal place. Don't write any decimal place. Don't be so smart and think, okay, 50, let's put 50.0, let's put 40.0. Yeah, don't do that. If you modify that, you're going to lose marks as well. So follow the numbers as is. And that goes as well with your responding variable, right? And when you record the values here, don't write the units. Your units are already in your header. Don't add 10 microampere, 20, and then, hearing, let's use that. And then we try to add 20 microampere. Yeah. Don't do this. Yeah, I know it's terrible writing. I said this app is not very friendly with my pen type. Yeah, don't do all this. Don't try to be too smart. Just keep it simple and just go with 10, 20, 30, yeah, without the units. Okay, so just write 10, 20, 30, 40, 50, and so on. And all the numbers that you write in here as well, follow the picture. Don't write any additional or less decimal place. You gotta write the exact number of decimal places as per the diagrams, which in this case there are none. Okay, and don't forget to draw the lines. Please use a ruler. I know I'm not using a ruler in this case, but please use a ruler, because neatness counts as well for a very good impression. Okay, so when you fill in these values as well, please remember to follow the decimal places as per the diagrams. So don't add decimal places, don't have less as well, right? Exactly as per the number of decimal places in the diagram. Like in this particular question, there are no decimal places, so let's keep it without decimal places. So for the completeness of this video, I'm just going to fill in the values. I'm just backtracking here to recall what the numbers are. So you've got 9, 17, 25, 33, 41. Okay, 9, 17, 25, 33, 41. So no decimal places. And of course, you've got to do the correction because we know the zero error, right? So you've got to take that off. 8, 16, 24, 32, and 40. Okay, so wait, before we move on, key things to point out to you once again. You must remember to, I'm going to mark this in pink. So that means for your final answer, do the ones in blue, but not the ones in pink, right? So just to highlight to you, please remember to have the units in your header. The values are running downwards and not across this way. And the decimal places must follow the measuring instrument. Now, one of the things, in this case, this particular example is not so good, or rather doesn't show clearly, but you must remember that the number of decimal places are not the same for the whole table. They're the same for the same column only. So you may come across examples where the first column has 1 decimal place, and then the second column has 2 decimal places, and the third column may have 4 decimal places. You may come across questions like that, and that's fine. Just remember, number of decimal places, same for the same column. Which means that sometimes if you get a perfect number, like let's say for example 1 decimal place and you get a round number like number 9, that one you add 9.0, okay, but not in this case. Let's go on to the graph now. So for the graph, I'm not going to draw a complete graph over here, but I will cover some of the important things that you must make sure you have when you are drawing a graph. So of course a graph paper is given to you here. Yeah, so like I said, I'm not going to draw the graph now. You guys, please, you draw the graph, but I will discuss with you some of the important things that you must make sure your graph has. Now, the title's already given to you, so you don't need to write the graph title, but you must make sure that in terms of the size, I'm just writing it here so that you will remember, size must be big. Now, I know that many of you have learned that, okay, as long as it's 50% of the graph paper, it's fine. I don't want you to aim for 50% because when you aim for 50%, that's all you get. So sometimes your 50% that you think you got a 50%, it's actually not 50%, it's less than 50%. And if you're like, okay, how do we measure this? Don't think about, oh, 50%. Just try to aim to get the graph to be as large as possible. Can you draw the axis along the edge? Yes, you can. Can you maximize? Let's say, for example, can you start here with your first value and the very last value? Yes, you can. Okay, as large as possible is the best in order to make sure that you can get your marks. Okay. Secondly, start from zero, which means that your graph that you plot here both must start from zero. This is only true for physics SPM and not for other sciences or physics in other syllabus programs. Okay, for SPM and SPM only, you must start from zero. And the reason for this is because it is to help us find the relationship to determine whether the relationship is a direct proportional one or differently. Your scale must be regular. Scale must be regular, meaning try to use multiples of 1, 2, or 5. For example, 1, 2, 3, 4, 5, or you can go 2, 4, 6, 8, or you can even go 4, 4, 8, 12. That's fine. 5, 10, 15, 20, it's fine. Try to avoid weird numbers like 3 and 7. So don't go 3, 6, 9, 12, or 7, 14, 21, even if the values in your table suggest that you can do so. Try not to do that because you could also lose marks. Okay? The reason why we want a regular scale is because we want a number that's easy to divide. So which means that, for example, let me explain to you why. Because if this was, for example, we put up to 2, it's very easy to divide. You see, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares here. Each square is 0.2. So if you had to try to interpolate a value in between, it's very easy to get that point. But if you have a weird number like 3, then you've got 0.3, 0.6, 0.9. If let's say you have to interpolate a value like 1, you're like, okay, 1 is somewhere in between the white boxes here. It's kind of weird and difficult to do so. That's why we don't like to use numbers that are difficult to divide. That's why the increments of 1, 1, 2, 3, 4, 5, 2, 4, 6, 8, or 5, 10, 15 works the best. Okay, so don't use 3. Okay, next. Okay, so in terms of plotting, please plot. Why isn't this showing up? When you plot, please use crosses, not points, because it's very difficult to see points like this, especially once you've drawn the line through. And if the examiner can't see your plotted points, they're not going to give marks. So make sure you use a nice clear cross with a thin line as possible. So make sure your pencil is sharp. So none of this, please. And no hanging graphs, please. Hold on. Yep, I have this problem all the time with this app. Okay. It's not showing up. Okay, no hanging. Wait, the words will appear soon. I'm so sorry, guys. Oh, this is not working out. Let's get rid of this. And let's use text then. I hope this works. Okay, yeah, I don't know what just happened. Sorry, guys. Like I said, it's a little bit rough around the edges because this app gives me a lot of problems. I've been trying to use a different app, but it wouldn't successfully record. So that's why I'm using this for the time being. Once I get a better app, I will use that for future videos. So no hanging graphs. Let's make this a little bigger so that you guys can see. Okay, not that big. Okay, I don't know where this came from. Let's try that again. It's so frustrating. Once I can get my spelling right. Okay, there we go. Okay, I don't know where this is coming from. Okay, I'm just going to try to use a text here. Oh gosh, I hope this doesn't let me down. Yeah, like I said, this app has been giving me a lot of problems. I'm really sorry, guys. If I can find a better app in the future, I'm going to use that instead. For the time being, let's just bear with me, all right? Yeah, I can make this bigger. Okay, never mind. Let's just go with this first. So remember, no hanging graphs. Now, what we mean by hanging graphs is this. If you have a graph, let's use a different color. Let's hope this shows up. Okay, if you have a graph which it's like this, it's floating in the middle, that's a hanging graph. So no hanging graphs, please. You've got to make sure that when you plot the graph, no matter where the plots are, you have to make sure, let me just use a different color for further emphasis here. Let's use this color, or you won't see it. Okay, let's just use black then. That you extend the line so that it at least touches the y-axis or the x-axis or starts from 0. Okay, so that way it's not hanging. Because the moment you have a hanging graph, you will lose 2 marks. 1 mark from the graph and 1 mark from the relationship. Now what I mean by relationship is this. Every time after you've plotted a graph, you will be expected to state the relationship between the two variables which you've plotted. Let me just get rid of this that has popped out of nowhere. So whenever you write the relationship, now if you have a hanging graph, no matter what answer you write, anything you write here will be automatically rejected. So make sure that you don't have a hanging graph. So the reason why the relationship you write here is rejected is because if your graph is hanging, we can't see for certain clearly what the relationship is. So how do you write the relationship? Now, in physics SPM, you will almost always get a linear graph. It's not true for all experiments, but for physics SPM, it's almost always guaranteed to be a linear graph. So if you get a linear graph, let's just sketch. Let me use a different color so that we can see it more clearly on the question paper. So if you get a graph like this is a direct proportional relationship. These graphs are increasing linearly, and this graph is decreasing linearly. But when you write out the relationship, please don't just write, oh, directly proportional or increasing linearly. You have to write it in full. What is directly proportional to what? What is increasing linearly to what? What is decreasing linearly to what? Right? So like in this case, I'll just scribble it here. Now let's use the text. Y is directly proportional to x. Now, of course, please don't write y and x. Please change the y and x to match what's in the question. So for example, if your graph that you got in this question is this, then you write IC is directly proportional to IB. If you get this either kind of graph, I'll just write in general here. Okay, I thought I'd change the color. Whoops, evidently that was not the change in color. I don't know why there's a border there. I really do not. This is very frustrating. I do not like this app. Okay, I don't even know why there's a text there. So, wait, hold on. Eventually it will come up. Okay, I thought I changed the color. I guess it didn't. Never mind, let's just go with that first so not to waste your time. Okay, y increases linearly with x. So of course, again, change the y and x to match the variables in this particular question. Okay, I'm trying to delete it, I swear. Sorry guys, next video will be a lot better. I promise. And then y, okay, now it's blue. Y decreases linearly with x. Let's get rid of this. Yeah, I can't seem to switch off the, there we go. Okay, so make sure you, if you get this kind of graphs, these are the kind of relationships you can write, but change the y and x to match the variables in the question accordingly. And there you go. So that's how you answer section A, question 1. So we're going to stop here for now, although I had planned to do question 2 as well. Let's keep question 2 for another video because I think it's already quite a lot to absorb uh, at this point. So I'll see you in the next video for paper 3, section A, question 2. Thanks so much for watching. I hope that this has been helpful and educational for you. Please don't forget to click like and subscribe. Thank you all for your support and see you in the next video.